Alright guys, welcome to Math 0314, Lesson 1.7, Absolute Value and Inequalities. So, we already know this game, inequalities, the only difference between absolute value and equations and absolute value and inequalities is how we deal with the inequality symbol. So, let's go through and see how we would deal with that. So, the first thing you would do is, just like in 1.6, you would solve the problem by isolating the absolute value. So here we would get absolute value of 3w plus 1 is less than 11. From here, the way we approach it is just like before. We rewrite it without the absolute value, and we have to consider two cases. So the second case is the one that is the interesting one, because remember earlier from section 1.6, I said that technically speaking, when we play with absolute value, it's a piecewise function that is x when x is greater than or equal to 0, and then it's negative x when x is less than 0. In other words, when x is a negative number, then you have to put a negative inside so it becomes positive. So the real reason why I'm pointing this out, though, is that what you want to realize on the right-hand side is that if I divide through by -1, we have to remember that we have to flip the inequality. And that's really the only big change. So when we solve these problems, we rewrite it with the absolute value by itself, and then we consider the two cases. One is exactly as is, and the other one we flip and negate. Okay. Other than that, it's the same exact process as what we've always been doing. So let's now solve this, see what we get as our answer. So I would subtract 1, 3w is less than 10, and then we would divide through by 3, and w would be 10 over 3. On the other side, we would subtract 1, 3w is greater than -12. And then when I divide through by 3, w is greater than -4. So we get an answer that says w is less than 10/3 and w is greater than -4. And to really understand what's going on, let's draw a picture. So if I draw a picture of this, 10/3 is over here. 10/3 is 3 1/3, and I'm not doing anything fancy. I know 9 divided by 3 is 3, and I have 1/3 left over. And w is greater than -4, so we'll put -4 over here. And these are parentheses because we're not including the values. So there may still be a question that emerges, which is it the answer just what's in between these two, or is it everything? And to answer that question, I implore you to go back to the original and test it. Well, we can use this version of the original and test it. So if what I'm trying to tell you is that if the answer extends beyond, let's say I use this. We said this is 3 1/3. Let's say I use 4. If I plug 4 in here, does it get me something true? Well, let's see. 4 times 3 is 12. 12 plus 1 is 13. Is the absolute value of 13 less than 11? And the answer to that is clearly no. So that's what tells me when I look here that this bit right here is a no-go. It doesn't exist. It's just what's in between. And this is also the thing that I love about math, and particularly this sort of math, is that there's no way for you ever really to miss a question, right? Because all you have to do is test what you have, plug it back into the original, and see if it's true. So in other words, the answer to this is that w is between -4 and 3 1/3. And that's our answer. Okay? So hopefully that makes sense. Let's look at the next one. My advice to you, and for most of this, you should be able to do this on your own. You really don't really need me. I'll work through the problems with you, but I think you can do this on your own. Pause the video now. Try it. Hopefully you can get it on your own. I'm going to assume now that you've given it a shot. Let's do it together. So again, you want to get the absolute value by itself. So I'm going to subtract 2. I'm going to get 2x plus 5. The absolute value of it is less than or equal to 9. We consider our two cases. I'm going to say 2x plus 5 is less than or equal to 9, and then 2x plus 5 is greater than or equal to negative 9. Notice I went ahead and just put the negative and flipped the inequality. And from here, we're just going to solve. So subtract 5, subtract 5, subtract 5, subtract 5. We're going to get 2x is less than or equal to 4. Here we're going to get 2x is greater than or equal to negative 14. This one comes out nicer. Divide through by 2. X is less than or equal to 2. Divide through by 2. X is greater than or equal to negative 7. Graphing it, remember this is including the value, so they're going to be in brackets. Here's negative 7, here's 2, and again, it's what's in between. Or the final answer is negative 7 to 2 in brackets. So, moving on to the next one, we have 3 is less than or equal to 1 plus absolute value of 1/2 x minus 5. Again, I encourage you to pause the video and try to do this on your own. I'm going to assume that you've done that, and let's see how we do this. So, more of the same, subtract 1, subtract 1. We're going to get 2 is less than or equal to the absolute value of 1/2 x minus 5. Again, we're going to consider the two cases, one if it's positive, and the other is if it's negative. Got the flip. And we just go through and solve. So the cool thing about math is that once you learn a strategy, you can always employ it. I don't like fractions, so I'm always going to multiply through by the denominator to every term. So 4 is less than or equal to x minus 10. And I'm going to do the same thing over here. So negative 4 is greater than or equal to x minus 10. And we're going to add 10 to both sides. 14 is less than or equal to x. Over here, I'm going to add 10 to both sides. 6 is greater than or equal to x. And we're going to graph this. So x is greater than 14 is here. And x is less than 6 is here. And so the question emerges here is that is the answer what they share in common, which is nothing, or is the answer negative infinity to 6 and 14 to infinity? And again, a nice way to see what's the case is if plug in. So let's say that the answer is both of them. So I'll take a number that's less than 6. I'm going to use 0 to be easy, make it easy. So notice I'm going to use this version here because it's cleaner. So if I plug in 0 here, I get the absolute value of negative 5, which is 5, and 5 is greater than or equal to 2, so that's okay. And then I'll take a value that's greater than 14, let's say 15. Actually, I'll take 16 to make it easy. So half of 16 is 8, 8 minus 5 is 3, and 3 is still greater than or equal to 2. So this scenario here is an OR, which is sometimes instead of OR, they'll replace OR with the union symbol, which is the same thing. So there you have it. Go ahead, if you haven't done so already, give a shot at number 4, and let's see how your work compares with mine. So I'm assuming that you've given this a go. Let's do this together now. We're going to subtract 1 again. Get 4 is less than the absolute value of 1/3 x minus 1. We're going to write down the two scenarios. Notice here I'm flipping the inequality. I'm going to multiply through by 3. I'm doing it on the right side because I don't have a lot of space. I'll just do it on the right side again to be consistent. And we will get 12 is less than x minus 3. And here we'll get negative 12 is greater than x minus 3. We'll add the 3. x is greater than 15, add the 3. X is less than negative 9. We'll graph it. X is greater than 15 is over here. X is less than negative 9 is over here. And that's my answer. And there you have it. So, hopefully that's not too bad. Moving on. We have this next scenario, so we'll do the same exact situation. Oh, by the way, again, always pause the video, try it on your own, then see what I do. Hopefully you pause the video, try it on your own, and now you're seeing what I'm doing. I'm going to subtract 7. And, oops, I get absolute value of 3d minus 5 is less than negative 3. And before I keep going on with this question and trying to figure out what the answer is, I have to remind myself that I am a human, not a robot. So I'm not just going to just consider 2 cases. I'm going to look at this and then ask myself, does it make sense? Does it make sense that an absolute value can be less than a negative 3? And I hope the answer to that is no, it doesn't make sense. And the question is why doesn't it make sense? And the answer to that question is it doesn't make sense because absolute values always turn up to be 0 or a positive number. So how can you get a 0 or a positive number that is less than negative 3? It's not possible. This again is no solution. Or the empty set. Okay? So you have, just like in the previous section, you have to ask yourself, does it make sense? So we can see here, oh, I wrote the same problem down. Wait. No, I didn't. Let's solve here. So now I'm going to subtract 7. Thought it was the same problem. It's actually different. And hopefully you noticed what the difference was, because I almost didn't. What's the difference between this problem and this one? The difference between the two is that this is greater than, so this is eating the absolute value, right? And so what this is saying now is we know the absolute value is a positive or 0, right? Like the absolute value of a value, the spectrum of solutions must be that the absolute value is equal to 0 or a positive number. So if that is true, every number, whether it's 0 or a positive number, will always be greater than negative 3. Hence, the answer to this question is going to be everything. There's nothing that doesn't work. Sometimes we see the symbol here, which means all reals. But all solutions work here. Okay? And you could challenge me on it. Pick any number. I will pick 0 here. So this would give me the absolute value of negative 5, which is 5 is greater than negative 3. And let's put negative 1,000. So negative 1,000 times 3 is negative 3,000. So that's negative 3,000 minus 5, which is negative 3,005. Absolute value of that is 3,005. It doesn't matter what you plug in. It's always going to be the case that it'll work. So I advise you to play around with numbers, and you'll see that it always works. One thing to... Yeah, let me leave it at that. Okay. All right, so number 7, you can see, hopefully you've attempted this on your own. You can very quickly see that you're still going to get the same effect, that you're going to get a negative value. So we're going to say, I'm just going to use this symbol here. It's not going to be true, right? You can't get an absolute value that's less than a negative number. And on this one, we can see, and I hope that you are actually doing this on your own before watching me. It's so blatantly obvious what's occurring here. I'm just giving you the same scenarios over again. We can see here that the absolute value is greater than negative 4, right? Which means, hopefully you said that everything works. Moving right along. Okay, so now we have 0. So again, we consider the case when it's positive, but then we would also consider the case that's negative. So I want you to see something here. So remember I said originally that if I wrote the negative case, I could just put it with the side that has the absolute value, and then we could divide through by -1. And then when I do that, when I divide through by -1, that would flip the inequality, and this would become 0. Okay, so these are my two scenarios, and I'm just going to rewrite the other one. And we'll just go through and we'll solve it. Do the same thing on the other side. And if we look at this, what we're getting is that x is greater than or equal to -1/2, and x is less than or equal to -1/2. And that would mean that it would be everything, right? And why does that make sense? Why? Why would that be the case? Well, again, we said that the absolute value of anything is going to be what? The absolute value of anything is going to be 0 or positive. Well, what are we saying here? This whole thing is saying that it's greater than or equal to 0. So of course it's going to work for everything. Okay, so hopefully that makes sense. What about here? So obviously when we look at these two, the solution is going to be the same because they're the same. The only difference is that and this one is not equal to. So here, remember we said the answers was one was that it was greater than 1/2. The other one is that it's less than 1/2. The one thing that we don't include is 1/2. Notice it doesn't have a line under here, so we're not including 1/2, right? So that is the only time it's not true. And if you think about it, that makes sense. I'm sorry, I said 1/2, but it's actually -1/2, right? And if we think about it, that makes sense because if I plug -1/2 in here, I will get 0, and this is not equal to 0. So the way we write this in math notation, especially interval notation, which is the most popular form, it's a little cumbersome because you have to write it all out, but it essentially looks like that. That essentially means that we're not including -1/2. It's everything but -1/2. Okay, hopefully that makes sense. Okay, this is another special sort of situation. Let's think about this for a little bit. If we solve this one, we're going to get 4x plus 2 is less than or equal to 0. And then we could also get 4x plus 2, the negative version, is less than or equal to 0. And as I solve this, I subtract 2. Subtract 2. 4x is less than or equal to -2, so x is less than or equal to -1/2. And here I am being silly. It's the same 4x plus 2. So on the other side, we're going to get the same thing. Well, let me just solve it. Let me not be lazy here. I'm going to divide through by -1 here. I'm going to get 4x plus 2 is greater than or equal to 0. Subtract 2. 4x is greater than or equal to -2. Divide through by 4. X is greater than or equal to -1/2. So we're getting that, make sure I'm looking at this right. Here we're getting that x is less than, here's -1/2, x is less than -1/2, and that's from this one, right? And on this one, let me choose color. On the green, this one, we're getting the other side. Right? So the question is, what about here? What is the answer? Well, again, I encourage you to plug in values, and so let me plug in, say, if I'm saying it's everything, let me just plug in 0, because that's easy. I'll get 2. 2 is less than or equal to 0. And that is not true, right? 2 is not less than or equal to 0. Okay? So what the heck is going on here? Because this is what we're getting as the answer, is it not? Well, really we're not. Okay? This right here, the way it's written, whenever the argument is on the left-hand side of the inequality, that means that it's an and statement. And when the argument is on the right-hand side, that means it's an or statement. Okay? So when we first did the first question, notice the position. Right? Then when we go back to the third question, which was an or, notice the position. Okay? I'm not a big proponent of that. I actually don't have that memorized. I just always plug in and check to see if it makes sense. See how I typically approach it. The other way to approach this is just to use a little common sense. And so if I apply a little common sense here and just look at this, right? If it's less than or equal to 0, right, we know absolute value must be positive, right? So this doesn't make sense. So the only value that is going to work is the value that gives me 0, which is -1/2. So notice this is the exact opposite of the previous question. That said the answer was -1/2. And here the answer is that only -1/2 works because that's the only value that gets me 0, because it says it's equal to 0. So if I asked you, if I took that equal to away, what would be the answer? Hopefully you answered, there's no solution, because there's no value, absolute value that's less than 0 that makes it true. Okay? So what I did here is I kind of went through all the various scenarios that you could have where it's greater than or equal to, it's greater than 0, or it's less than or equal to 0, and then I told you also when it doesn't exist, what would it be? Okay? So, but the big point is, ask yourself at the end, does my answer make sense? The answer on a test is, if I plug it in, does it really work for every value? Take your time. Okay, so when I look at this question, now I'm going to just solve this using common sense. Greater than or equal to 0. So what do you think the answer is? So hopefully you've said what you think the answer is. You don't have to do any math here. You just have to think. And the answer here is everything works. Right? Everything that exists inside absolute value will be 0 or greater than 0. So any value you plug in x will produce 0 or a number greater than 0. So everything works. Hopefully that makes sense. On 13 is just like 12, just doesn't have 0. So everything works except when 3x minus 1 equals 0, because that is not a possibility. I just did that very fast. X equals 1/3. By the way, I hope you're at a point now that you can see very quickly that x would be 1/3. Why? Because when 3x minus 1 equals 0, we know we're going to add 1 over, and then we're going to divide by 3. Right? So it's very easy to see that 3x minus 1 equals 0 is 1 equals 3x, and then divide by 3, you get 3. And what I'm hoping happens, I know this class is a little compressed, but I'm hoping that practicing all these problems, if you're watching all these videos, you really genuinely are working through the problems, you start to really get like a rhythm with doing these, and they just become increasingly easy to do. I hope. So the only time that this is not true is when x equals 1/3. So the answer to this is everything but 1/3. And there we have it. Moving right along. Less than or equal to 0. Here we know it's true as long as it's only true for 0, because absolute value is only 0 or a positive value. So here the answer is x equals 1/3. Right? Because it only works with 1/3. Right? Any other value, you're going to get something greater. You're going to get a positive value, and that's going to give you, positive numbers are not less than 0 or equal to 0. And I think that's it. Yep. All right, guys. So hopefully that makes sense. This is more of a conceptual section than anything else, I think, towards the end. But this is only at the end that we have those sorts of questions. For the most part, you're doing exactly what you've been doing with absolute value. Just remember, when you have a negative, you got to divide through, and you flip the inequality, and you should be fine. So hopefully this went well, and we're on the chapter 2 next time. See you guys when I see you guys.